Good afternoon, all. So we are learning about Bayes theorem. Okay, now we'll learn about we have also already learned about uncertainty. What is uncertainty, and what are the leading causes of uncertainty? That is, the information occurred from unreliable sources, experimental errors, equipment fault, temperature variation, and the climate change. This can probably lead to the uncertainty. Okay, so why we go for probabilistic reasoning? When unpredictable event occurs, when specifications or probabilities of predicates become too large to handle. That is, it's very hard to manage those resources which are available to predict the future occurrence of event. Okay, and also when an unknown error occurs during an experiment, we go for probabilistic reasoning. There are two ways to solve the problems in the uncertainty knowledge. That is the Bayes rule and the Bayesian statistics. Okay, so what is what is the probability? It can be defined as that any uncertain event that will occur, that is either it will be 0 to 1, and 0 indicates the total uncertainty in an event A, and A1 indicates the total certainty, that is most probably it is likely to occur. Okay, so the probability of occurrence, this will be asked in problems. So what it is, probability of occurrence will be desired number of outcome divided by total how many numbers of occurrences are there. Okay, and probability of not, that is the tilde symbol between before a, it presents that probability of a not happening event. Okay, so the not happening plus the happening of the event, that is P of A, will be equal to 1. So what is the event? For it, event is each possible outcome of a variable is called as the event. Whatever occurs in an in a variable, that is the changes or the static alone, the whatever the part it occurs, it is an event. For example, rolling a dice. Okay, so we'll get any number when we roll the dice, so that is an event. That is a each possible outcome of a variable is called as the event. So variable here is the dice. Okay, it keeps on changing its position when we roll it. So each possible outcome of a variable is called event, and sample space, what it is a collection of all possible events in a sample space. That is, if you roll the dice 8 times, what is the occurrence of numbers of each numbers? That will be the collection of all possible events. Okay, and that is the sample space. What is random variables? It used to represent the events and the objects in the real world. So the prior probability of an event is probability computed before observing the new information. That is the prior probability before the occurrences of the event. So after, that is posterior, after the event has occurred, it is the posterior probability. So what is the conditional probability? It is the probability of an occurring an event when another event has already happened. That is, if it rains, then the climate will be wet. So that is either it should be happen prior or posterior. Okay, so here it is a conditional probability, the probability of occurring an event when another event has already happened. Let's suppose we calculate A when B has occurred. That is, A when B has occurred is equal to the P of A intersection B. That is the probability of A under the conditions of B, and it can be written by the joint probability. That is the P of A or B is equal to probability of A intersection B divided by probability of B. And what is the probability of B? It is the marginal probability of B. So if a probability of A is given and we need to find the probability of B, then B over A. Okay, that is the probability of occurrences of B over A will be given by probability of A intersection B divided by probability of A. So it can be explained by using the Venn diagram. This is the Venn diagram. We already have learned it in the set language and probability. Okay. And for example, consider here there are 70 students who like English and 40 students who likes English and mathematics. So 40 divided by 100 is equal to 0.4. Okay. And then what is the percentage of students who those who like English also and like mathematics? So we have to find either the occurrences of English or mathematics. Okay. So A or B will be given by P of A intersection B. That is the probability that people like both. That is A intersection B, which will be given by 40%, which is 40 divided by 100, which is equal to 0.4. And those who like only English, that is the 70%, which is 70 divided by 100, which is equal to 0.7. So 0.4 divided by 0.7 will be getting the 57 percentage. So this is, there is a chance the person who likes English and mathematics will be 57 percentage. Okay, so this is the Bayes theorem. So who formulated it? It is Thomas Bayes, and the Bayesian inference is an application of Bayes theorem, which is fundamental to the Bayesian statistics. Okay, so it is a way to calculate P of B divided by A with the knowledge of C and B. So, see here in this example, if cancer corresponds to one age, then by using Bayes theorem, we can determine the probability of the cancer more accurately with the help of the age. Okay, so we create a chart of the cancer patient's age and the symptoms and the probability of how many percentage they are having the tumorous cells. We can calculate it and we can predict if a person comes under this age with the condition of so and so, he is more probable to have the cancer or not. Okay, so that is the prediction algorithm. So for that we use the what is the rule for it? P of A of B, that is the occurrences of A over B, will be given by probability of B over A, probability of A divided by probability of B. Okay, so this equation is a basic for all the AI applications in for the probabilistic inference. And A of B is known as the posterior, because we need to calculate A prior to B. Okay, and similarly B of A, it is the likelihood that we consider the hypothesis is true, then we calculate the probability of evidence. Okay, so P of A is called as the prior probability and P of B is called as the marginal probability. So the occurrences of A over B will be the summation of B over A into probability of A divided by the total number of A and B over A. Okay, so this is the probability rule. So we can put it on other terms such as, for example, cause and effect. Okay, so cause and effect will be given as probability of effect over cause, probability of cause, and probability of effect. Okay, so this is the formula for it. So by heart this formula, this will be surely asked for 2 marks or 3 marks. Okay, so question 1, let's see here. A doctor is aware that disease meningitis causes a patient to have a stiff neck, and it occurs 80% of the time. Okay, so he is also aware of some facts which is given below. The known probability that a patient has meningitis is 1 out of 30,000. Okay, and the person who has stiff neck is about 2%. So we have to find whether this is the cause for that. That is, the meningitis is a cause for stiff neck. So normally stiffness persons will get nearly 2% of disease related to meningitis. Okay, so here for the proportion, what is the formula we learned? P of B over A will be given by A over B into probability of B divided by probability of A. Okay, so here the probability of A, it is the effect. So what is the effect? It is a stiff neck. So 2 divided by 100, which will be 0.02. And first one is, what is the probability of A over B? What is the effect and cause? That is the 0.8. Okay, so a person with meningitis will have the stiff neck. So here, so here, the probability of what is point 0.8? Point 0.8 is the this one. Okay, that the disease that causes stiff neck, that is the meningitis that causes stiff neck, is 80%. So 80% is equal to point 0.8 into 1 out of, that is the cost, 1 out of 30,000. Okay, which is equal to, it is very low percent. So we can assume that one per patient out of 750% have meningitis disease related with the stiff neck. Okay, so similarly, see this problem. So from the standard deck of playing cards, a single card is drawn. The probability that the card is king is 4 out of 52. Then calculate the posterior probability, that is the P of king over face, which means the drawn face is a king card. Okay. So here what we do is, what is the formula for it? So we want to find P of king into face. Then obviously here it will be P of face into king divided by P of face. Okay. So what is the probability of probability that the king card will be drawn is equal to 4 by 52, which is equal to 1 by 13. So there is a 4 king, right? In a card of 50, in a deck of 52 cards, there will be 4 king. And so 4 divided by 52, which is equal to 1 by 13. And probability that a card is a face card is 3 by 13, and the probability of king face of king will be equal to the probability of face card when we assume it is a king. Okay, so putting all this in the equation, we will get probability of king divided by face is equal to 1 into 1 by 13 divided by 3 by 13, which is equal to the 1 by 3. So the probability of face card is a king card. Okay. So what are the some applications where we apply this Bayes theorem is, it is used to calculate the next step of the robot when the already executed step is given. It helps in weather forecasting. It helps to solve the Monty Hall problem, and it is the Bayesian belief network in artificial intelligence and dealing with probabilistic events. What are the probability for predictions? To solve a problem which has uncertainty, we can define a Bayesian network as, it is a probabilistic graphical model which represents a set of variables and their conditional dependencies using a directed acyclic graph. Okay, so here this is the acyclic graph which has a node, which has an arc, and which will be connected to the node ends. Okay, so this is the arc for it, and I'll be giving some problems to solve it using the Bayes theorem and see. Okay, so that thing we can have it as an exercise for today, and now we'll be learning about some fillers. Okay, what is fillers? So before even going for it, Phyllis will see about what is knowledge representation in this video.
We'll talk about the and we will wrap it up with the examples and approaches for knowledge representation in AI. Now, before we get started, don't forget to subscribe to EduReka's YouTube channel and press the bell icon to get latest updates. Also, if you are looking for any online courses on data science, check the description box below. So, what is knowledge representation actually? Now, knowledge representation in AI describes the representation of any knowledge. Basically, it is a study of how the beliefs, intentions, and judgments of an intelligent agent can be expressed suitably for automated reasoning. Now, one of the primary purposes of knowledge representation includes modeling intelligent behavior for an agent. Knowledge representation and reasoning, also known as KR or the KRR, represents information from the real world for a computer to understand and then utilize this knowledge to solve complex real life problems, like communicating with human beings in natural language. Now, knowledge representation as AI is not just about storing data in a database. It allows a machine to learn from that knowledge and behave intelligently like a human being. Now, there are different kinds of knowledge that need to be represented in AI, such as the objects, events, performance, facts, then we have meta knowledge and the knowledge base. So, these were the different kinds of knowledge that you need to represent. And now that you know about knowledge representation in AI,
As a VFX artist, my world can be anything I want it to be.
let's move on and know about the different types of knowledge here. Now, talking about the different types of knowledge, there are 5 types. Talking about the first one, we have declarative knowledge. Now, this includes concepts, facts, and objects expressed in a declarative sentence. Then we have the structural knowledge. Now, it is a basic problem solving knowledge that describes the relationship between concepts and objects. Next up, we have the procedural knowledge. Now, this is responsible for knowing how to do something and includes rules, strategies, procedures, etc. The fourth one is the meta knowledge. Now, this defines knowledge about other types of knowledge. And finally, we have the heuristic knowledge. Now, this one represents some expert knowledge in the field or subject. So, these were the 5 important types of knowledge in AI. Now, let's have a look at the cycle of knowledge representation and how it actually works. So, talking about the cycle of knowledge representation, artificial intelligence systems usually consist of various components to display their intelligent behavior. Now, these components include perception, learning, knowledge representation, and reasoning. Then we have planning and finally execution. Now, here is an example to show the different components of the system and how it works. Now, this diagram shows the interaction of an artificial intelligence system with the real world and the components involved in showing the intelligence. So, first of all, the perception component retrieves data or information from the environment. Now, with the help of this component, you can retrieve data from the environment, find out the source of noises, and check if the AI was damaged by anything. Also, it defines how to respond when any sense has been detected. The next component is the learning component. Now, this learns from the captured data by the perception component. Here, the goal is to build computers that can be taught instead of programming them. Now, learning focuses on the process of self improvement. In order to learn new things, the system requires knowledge acquisition, inference, acquisition of heuristics, faster searches, etc. Now, moving on to the next components, these are the main components in the cycle, that is, the knowledge representation and reasoning. Now, this shows the human like intelligence in the machines. Knowledge representation is all about understanding intelligence. Instead of trying to understand or build brains from the bottom up, its goal is to understand and build intelligent behavior from the top down and focus on what an agent needs to know in order to behave intelligently. Also, it defines how automated reasoning procedures can make this knowledge available as needed. And finally, we have the planning and execution. Now, these components depend on the analysis of knowledge representation and reasoning. Here, planning includes giving an initial state, finding their preconditions and effects, and a sequence of actions to achieve a state in which a particular goal holds. Now, once the planning is completed, the final stage is the execution of the entire process. So, this was all about the cycle of knowledge representation in artificial intelligence. Now, let's move on and understand the relationship between knowledge and intelligence. So, what is this relation between knowledge and intelligence? In the real world, knowledge plays a vital role in intelligence as well as creating artificial intelligence. It demonstrates the intelligent behavior in AI agents or systems. Now, it is possible for an agent or system to act accurately on some input only when it has the knowledge or experience about the input. So, here is an example to understand this relationship better. So here there is one decision maker whose actions are justified by sensing the environment and using knowledge. But if we remove this knowledge part from here, it will not be able to display any intelligent behavior. So this is the relationship between a knowledge and intelligence. You need the knowledge in order to display any intelligent behavior. That is, for any intelligent system, you need knowledge first. So now that you know the relationship between knowledge and intelligence, let's move on to the techniques of knowledge representation in AI. Now, talking about the techniques, there are 4 techniques of representing knowledge. These 4 techniques include logical representation, semantic network representation, frame representation, and production rules. So, talking about the first one, logical representation is a language with some definite rules which deal with propositions and has no ambiguity in representation. It represents a conclusion based on various conditions and lays down some important communication rules. Also, it consists of precisely defined syntax and semantics which supports the sound inference. Each sentence can be translated into logics using syntax and semantics. So, what is the difference between a syntax and a semantic? Now, for syntax, it decides how we can construct legal sentences in logic, and it determines which symbol we can use in knowledge representation. Also, how to write those particular symbols. But when it comes to semantics, semantics are basically the rules by which we can interpret the sentence in the logic. Also, it assigns a meaning to each of these sentences. So let's talk about some of the advantages and disadvantages of this representation. Now, logical representation helps to perform logical reasoning. This representation is also the basis for the programming languages. These are some of the advantages of logical representation. Talking about the disadvantages, logical representations have some restrictions and are challenging to work with. Now, this technique may not be very natural and inference may not be very efficient. Now, talking about the next technique, we have the semantic network representation. Now, semantic networks work as an alternative of predicate logic for knowledge representation. Now, in semantic networks, you can represent your knowledge in the form of graphical networks. This network consists of nodes representing objects and arcs which describe the relationship between these objects. Also, it categorizes the object in different forms and links those objects. Now, the representation consists of 2 types of relation. First one is an is-a relationship, which is also known as the inheritance, and then we have another kind of relation. Now, talking about some of the advantages, semantic networks are a natural representation of knowledge. It also conveys meaning in a transparent manner, and these networks are simple and very easy to understand. But talking about the disadvantages, semantic networks take more computational time at runtime, and these are inadequate as they do not have any equivalent quantifiers. Also, these networks are not intelligent and depend on the creator of the system. So, this was about the semantic network representation. Now, let's move on to the next one, which is the frame representation. Now, a frame is a record like structure that consists of a collection of attributes and values to describe an entity in the world. Now, these are the AI data structure that divides knowledge into substructures by representing stereotype situations. Basically, it consists of a collection of slots and slot values of any type and size. Slots also have names and values which are called the facets. Moving on to the advantages, it makes the programming easier by grouping the related data. Frame representation is easy to understand and visualize. Also, it is very easy to add slots for new attributes and relations. Also, it is easy to include default data and search for the missing values. Talking about the disadvantages, in frame system inference, the mechanism cannot be easily processed. The inference mechanism cannot be smoothly processed by the frame representation either. Also, it has a very generalized approach. Now, moving on to the final technique, we have the production rules. Now, in production rules, agent checks for the condition, and if the condition exists, then production rule fires and corresponding action is carried out. The condition part of the rule determines which rule may be applied to a problem, whereas the action part carries out the associated problem solving steps. Now, this complete process is called a recognize act cycle. The production rule system consists of three main parts. The first one is definitely the set of production rules. Then we have a working memory, and finally, the recognize act cycle.
If you feel that you can never speak English fluently, I want to show you something. This
Now, talking about the advantages and disadvantages. First up is the advantages, where the production rules are expressed in natural language. And the production rules are highly modular and can be easily removed or modified. But talking about the disadvantages, it does not exhibit any learning capabilities and does not store the result of the problem for future users. Now, during the execution of the program, many rules may be active. Thus, the rule-based production systems are inefficient. So these were the four important techniques for knowledge representation in AI. So now let's have a look at the requirements for these representations. Now, a good knowledge representation system must have properties like the representational accuracy. It should represent all kinds of required knowledge. Also, it must have inferential adequacy. It should be able to manipulate the representational structures to produce new knowledge corresponding to the existing structure. It also must have the inferential efficiency. So, the ability to direct the inferential knowledge mechanism into the most productive directions by storing appropriate guides. Then, finally, it must have the acquisitional efficiency as well. That is, the ability to acquire new knowledge easily using automatic methods. So, these are some of the important requirements for the knowledge representation in AI. Now, let's understand some of the approaches of this knowledge representation with examples. So the first approach is a simple relational knowledge. Now, this is the simplest way of storing facts, which uses the relational method. Here, all the facts about a set of the object are set out systematically in columns. Also, this approach of knowledge representation is famous in database systems where the relationship between different entities is represented. Now, taking an example, you can see that we have three different columns like name, age, and employee ID, and we have three different names along with their age and employee IDs. So this is how you represent a simple relational knowledge. It is the simplest way of defining. You just have to take the name, age, and employee ID and define the relation. Moving on to the next approach, we have the inheritable knowledge. Now, in the inheritable knowledge approach, all data must be stored into a hierarchy of classes and should be arranged in a generalized form or a hierarchical manner. Also, this approach contains inheritable knowledge, which shows a relation between instance and class, and it is called the instance relation. Now, in this approach, objects and values are represented in boxed nodes. So here you can see the example where we have two different players, Danny and Peter, who plays two different games such as cricket and football. But they both are known as players and they both play for the under 19 teams. So you can see the relationship here. For Danny, cricket, and Peter, football, it's an instance. But when you compare the relationship of cricket, football with the player and the under 19, it's a is a relationship, which is also the inheritance. Now, the final approach is the inferential knowledge. Now, the inferential knowledge approach represents knowledge in the form of formal logic. Thus, it can be used to derive more facts. Also, it guarantees correctness. So here, if we take an example, you can see that we have first statement, which is John is a cricketer. Then we have another statement which says all cricketers are athletes. So you can also represent this as cricketer, who is John, and give the relationship as cricketers are athletes. So here you are checking out the relationship between John, cricketer, and athletes. And also this helps you and guarantees correctness in your relationship. So this is the final approach, which is the inferential knowledge. And these were some of the important approaches along with their examples that you need to know for knowledge representation in AI. With this, we have come to the end of today's session, and
So this is about knowledge representation, and we learned about the probability theorem. That is the Bayes theorem. We learned it. Next class we'll be seeing about the non-monotonic reasoning and the monotonic reasoning. What are the difference between both, and what are filters and slots? How to use it? Okay. So we'll learn about it in the next class. Now answer your attendance. Five 5001,
Present, ma'am.
5003, second 5004. Abhishek. Five 5007.
Yes, ma'am.
5000. 1 minute. 5008.
Present, ma'am.
14.
Present, ma'am. Present, ma'am.
15,
Present, ma'am.
16. 17. Sorry, 21.
Present, ma'am.
22.
Present, ma'am.